H215B20, H215A20, H216B20, H217B20, H218B20. 4, 3, 2, 1. 4, 3, 2, 1. H216A20, H217A20, H218A20. Terabytes -1. Figure 4-82. Wire identification at a terminal block. While the preferred method is to stamp the identification marking directly on the wire or on sleeving, other methods are often employed. One method uses a marked sleeve tied in place. The other uses a pressure-sensitive tape. Figure 4-83, pressure-sensitive tape. Zs 15. Sleeve marker tied in place. XYZ 15. Figure 4-83. Alternate methods of identifying wire bundles. Electrical wiring installation. The following recommended procedures for installing aircraft electrical wiring are typical of those used on most types of aircraft. For purposes of this discussion, the following definitions are applicable. 1. Open wiring, any wire, wire group, or wire bundle not enclosed in conduit. 2. Wire group, two or more wires in the same location, tied together to identify the group. 3. Wire bundle, two or more wire groups tied together because they are going in the same direction at the point where the tie is located. The bundle facilitates maintenance. 4. Electrically protected wiring, wires that include in the circuit protections against overloading, such as fuses, circuit breakers, or other limiting devices. 5. Electrically unprotected wiring, wires, generally from generators to main bus distribution points, that do not have protection, such as fuses, circuit breakers, or other current limiting devices. Wire groups and bundles. Grouping or bundling certain wires, such as electrically unprotected power wiring and wiring to duplicate vital equipment, should be avoided. Wire bundles should generally be limited in size to a bundle of 75 wires, or 2 inches in diameter where practicable. When several wires are grouped at junction boxes, terminal blocks, panels, etc., the identity of the group within a bundle can be retained. Figure 4-84. Bundle tie, group tie, bundle tie. Figure 4-84. Group and bundle ties. Twisting wires. When specified on the engineering drawing, parallel wires must be twisted. The most common examples are 1. Wiring in the vicinity of magnetic compass or flux valve. 2. Three-phase distribution wiring, and 3. Certain other wires, usually radio wiring. Twist the wires so that they lie snugly against each other, making approximately the number of twists per foot as listed in figure 4-85. Always check wire insulation for damage after twisting. If the insulation is torn or frayed, replace the wire. #22, #20, #18, #16, #14, #12, #10, #8, #6, #4. 2 wires, 3 wires. 10, 10, 9, 8, 7 and 1/2, 7, 6 and 1/2, 6, 5, 4. 10, 10, 8 and 1/2, 7, 6 and 1/2, 6, 5 and 1/2, 5, 4, 3. Figure 4-85. Recommended number of twists per foot. 4-51. Spliced connections in wire bundles. Spliced connections in wire groups or bundles should be located so that they can be easily inspected. Splices should also be staggered so that the bundle does not become excessively enlarged. Figure 4-86. All non-insulated splices should be covered with plastic, securely tied at both ends. Slack in wiring bundles. Single wires or wire bundles should not be installed with excessive slack. Slack between supports should normally not exceed 1/2 inch. This is the maximum it should be possible to deflect the wire with normal hand force. However, this may be exceeded if a wire bundle is thin and the clamps are far apart. But the slack should never be so great that the wire bundle can abrade against any surface it touches. Figure 4-87. A sufficient amount of slack should be allowed near each end of a bundle to 1. Permit easy maintenance. 2. Allow replacement of terminals. 3. Present mechanical strain on the wires, wire junctions, or supports. 4. Permit free movement of shock and vibration mounted equipment. And 5. Permit shifting of equipment for purposes of maintenance. Bend ready. Bends in wire groups or bundles should not be less than 10 times the outside diameter of the wire group or bundle. However, at terminal strips, where wire is suitably supported, at each end of the bend, a minimum radius of 3 times the outside diameter of the wire, or wire bundle, is usually acceptable. There are exceptions to these guidelines in the case of certain types of cable. For example, coaxial cable should never be bent to a smaller radius than 6 times the outside diameter. Routing and installation. All wiring should be installed so that it is mechanically and electrically sound and neat in appearance. Whenever practicable, wires and bundles should be routed parallel with, or at right angles to, the stringers or ribs of the area involved. An exception to this general rule is the coaxial cables, which are routed as directly as possible. The wiring must be adequately supported throughout its length. A sufficient number of supports must be provided to prevent undue vibration of the unsupported lengths. All wires and wire groups should be routed and installed to protect them from 1. chafing or abrasion. 2. High temperature. 3. Being used as handholds, or as support for personal belongings and equipment. 4. Damage by personnel moving within the aircraft. 5. Damage from cargo stowage or shifting. 6. Damage from battery acid fumes, spray, or spillage. And 7. Damage from solvents and fluids. Figure 4-86. Staggered splices in wire bundle. 1/2. Maximum with normal hand pressure. Figure 4-87. Slack in wire bundle between supports. 4-52. Protection against chafing. Wires and wire groups should be installed so that they are protected against chafing or abrasion in those locations where contact with sharp surfaces or other wires would damage the insulation. Damage to the insulation can cause short circuits, malfunctions, or inadvertent operation of equipment. Cable clamps should be used to support wire bundles at each hole through a bulkhead. Figure 4-88. If wires come closer than 1/4 inch to the edge of the hole, a suitable grommet is used in the hole. Figure 4-89. 1/4. Minimum clearance. Cable clamp. Angle bracket with 2-point fastening. Figure 4-88. Cable clamp at bulkhead hole. Wires less than 1/4 from hole edge. Approved grommet. Sometimes, it is necessary to cut nylon or rubber grommets to facilitate installation. In these instances, after insertion, the grommet can be secured in place with general-purpose cement. The slot should be at the top of the hole, and the cut should be made at an angle of 45 degrees to the axis of the wire bundle hole. Protection against high temperature. To prevent insulation deterioration, wires should be kept separate from high-temperature equipment, such as resistors, exhaust stacks, heating ducts. The amount of separation is usually specified by engineering drawings. Some wires must be run through hot areas. These wires must be insulated with high-temperature rated material, such as asbestos, fiberglass, or Teflon. Additional protection is also often required in the form of conduits. A low-temperature insulated wire should never be used to replace a high-temperature insulated wire. Many coaxial cables have soft plastic insulation, such as polyethylene, that is especially subject to deformation and deterioration at elevated temperatures. All high-temperature areas should be avoided when installing these cables. Additional abrasion protection should be given to asbestos wires enclosed in conduit. Either conduit with a high-temperature rubber liner should be used, or asbestos wires can be enclosed individually in high-temperature plastic tubes before being installed in the conduit. Protection against solvents and fluids. Avoid installing wires in areas where they are subjected to damage from fluids. Wires should not be placed in the lowest 4 inches of the aircraft fuselage, except those that must terminate in that area. If there is a possibility that wiring without a protective nylon outer jacket may be soaked with fluids, plastic tubing should be used to protect it. This tubing should extend past the exposure area in both directions, and should be tied at each end. If the wire has a low point between the tubing ends, provide a 1/8 inch drainage hole. Figure 4-90. This hole should be punched into the tubing after the installation is complete, and the low point definitely established by using a hole punch to cut a half circle. Care should be taken not to damage any wires inside the tubing when using the punch. Wire should never be routed below a battery. All wires in the vicinity of a battery should be inspected frequently. Wires discolored by battery fumes should be replaced. Figure 4-89. Cable clamp and grommet at bulkhead hole. 4-53. Figure 4-91. Separation of wires from plumbing lines. Figure 4-90. Drainage hole in low point of tubing. Protection of wires in wheel well area. Wires located in wheel wells are subject to many additional hazards, such as exposure to fluids, pinching, and severe flexing in service. All wire bundles should be protected by sleeves of flexible tubing securely held at each end. There should be no relative movement at points where flexible tubing is secured. These wires and the insulating tubing should be inspected carefully at very frequent intervals, and wires or tubing should be replaced at the first sign of wear. There should be no strain on attachments when parts are fully extended, but slack should not be excessive. Routing precautions. When wiring must be routed parallel to combustible fluid or oxygen lines for short distances, as much separation as possible should be maintained. The wires should be on a level with, or above, the plumbing lines. Clamps should be spaced so that if a wire is broken at a clamp, it will not contact the line. Where a 6-inch separation is not possible, both the wire bundle and the plumbing line can be clamped to the same structure to prevent any relative motion. If the separation is less than 2 inches but more than 1/2 inch, 2 cable clamps back to back can be used to maintain a rigid separation only and not for support of the bundle. Figure 4-91. No wire should be routed so that it is located nearer than 1/2 inch to a plumbing line, nor should a wire or wire bundle be supported from a plumbing line that carries flammable fluids or oxygen. Wiring should be routed to maintain a minimum clearance of at least 3 inches from control cables. If this cannot be accomplished, mechanical guards should be installed to prevent contact between wiring and control cables. Installation of cable clamps. Cable clamps should be installed with regard to the proper mounting angle. Figure 4-92. The mounting screw should be above the wire bundle. It is also desirable that the back of the cable clamp rest against a structural member where practicable. Figure 4-93 shows some typical mounting hardware used in installing cable clamps. Be sure that wires are not pinched in cable clamps. Where possible, mount them directly to structural members. Figure 4-94. Dangerous angles. 45 degrees max. Safe angles. 45 degrees max. Figure 4-92. Proper mounting angle for cable clamps. Clamps can be used with rubber cushions to secure wire bundles to tubular structures. Figure 4-95. Such clamps must fit tightly but should not be deformed when locked in place. 4-54. Cable clamps. Screw. Plain washers. Nut self-locking nut. Lock washer split lock washer external teeth. Figure 4-93. Typical mounting hardware for cable clamps. Cable clamps. Tubular structure. Correct. Rubber cushion. Angle, member, Z, member. Clamp. Angle bracket. Cable clamp. Wire is pinched in clamp. Figure 4-94. Mounting cable clamps to structure. Lacing and tying wire bundles. Wire groups and bundles are laced or tied with cord to provide ease of installation, maintenance, and inspection. This section describes and illustrates recommended procedures for lacing and tying wires with knots that hold tightly under all conditions. For the purposes of this discussion, the following terms are defined. 1. Tying is the securing together of a group or bundle of wires by individual pieces of cord tied around the group or bundle at regular intervals. 2. Lacing is the securing together of a group or bundle of wires by a continuous piece of cord forming loops at regular intervals around the group or bundle. Figure 4-95. Installing cable clamps to tubular structure. The material used for lacing and tying is either cotton or nylon cord. Nylon cord is moisture and fungus resistant. But cotton cord must be waxed before using to give it these necessary protective characteristics. Single cord lacing. Figure 4-96 shows the steps in lacing a wire bundle with a single cord. The lacing procedure is started at the thick end of the wire group or bundle with a knot consisting of a clove hitch with an extra loop. The lacing is then continued at regular intervals with half hitches along the wire group or bundle and at each point where wire or wire group branches off. The half hitches should be spaced so that the bundle is neat and secure. 4-55. Step. Tarting knot. Pull here until tight before finishing knot. Cord crosses under loop. Step. R2. Starting knot tightened. Final knot. Step. Intermediate half hitches. Trim to 3/8 minimum. First part of final knot tightened step. R-tie. Figure 4-96. Single cord lacing. The lacing is ended by tying a knot consisting of a clove hitch with an extra loop. After the knot is tied, the free ends of the lacing cord should be trimmed to approximately 3/8 inch. Double cord lacing. Figure 4-97 illustrates the procedure for double cord lacing. The lacing is started at the thick end of the wire group or bundle with a bowline on a bite nut. Figure 4-97A at regular intervals along the wire group or bundle, and at each point where wire branches off. The lacing is continued using half hitches, with both cords held firmly together. The half hitches should be spaced so that the group or bundle is neat and secure. The lacing is ended with a knot consisting of a half hitch, continuing one of the cords clockwise, and the other counterclockwise, and then tying the cord ends with a square knot. The free ends of the lacing cord should be trimmed to approximately 3/8 inch. Lacing branch offs. Figure 4-98 illustrates a recommended procedure for lacing a wire group that branches off the main wire bundle. The branch off lacing is started with a knot located on the main bundle just past the branch off point. Continue the lacing along the branched off wire group using regularly spaced half hitches. If a double cord is used, both cords should be held snugly together. The half hitches should be spaced to lace the bundle neatly and securely. End the lacing with the regular terminal knot used in single or double cord lacing, as applicable. And trim the free ends of the lacing cord neatly. Tying. All wire groups or bundles should be tied where supports are more than 12 inches apart. Ties are made using waxed cotton cord, nylon cord, or fiberglass cord. Some manufacturers permit the use of pressure-sensitive vinyl electrical tape. When permitted, the tape should be wrapped 3 turns around the bundle and the ends heat sealed to prevent unwinding of the tape. Figure 4-99 illustrates a recommended procedure for tying a wire group or bundle. The tie is started by wrapping the cord around the wire group to tie a clove hitch knot. Then, a square knot with an extra loop is tied and the free ends of the cord trimmed. Temporary ties are sometimes used in making up and installing wire groups and bundles. Colored cord is normally used to make temporary ties, since they are removed when the installation is complete. Whether lacing or tying, bundles should be secured tightly enough to prevent slipping, but not so tightly that the cord cuts into or deforms the insulation. This applies especially to coaxial cable, which has a soft electric insulation between the inner and outer conductor. Coaxial cables have been damaged by the use of lacing materials, or by methods of lacing or tying wire bundles that cause a concentrated force on the cable insulation. Elastic lacing materials, small diameter lacing cord, and excessive tightening deform the interconductor insulation and result in short circuits or impedance changes. Flat nylon braided waxed lacing tape. 4-56. Starting knot for branch off. Branch off lacing. Step. Outline on a bite as starting knot. Starting knot tightened. Half hitch required at branch off point. Main bundle lacing. Step. Intermediate half hitches. Step C final knot. Step. Enal knot. Figure 4-97. Double cord lacing. Figure 4-98. Lacing a branch off. Should be used for lacing or tying any wire bundles containing coaxial cables. The part of a wire group or bundle located inside a conduit is not tied or laced. However, wire groups or bundles inside enclosures, such as junction boxes, should be laced only. Cutting wire and cable. To make installation, maintenance, and repair easier, runs of wire and cable in aircraft are broken at specified locations by junctions, such as connectors, terminal blocks, or buses. Wrap cord twice over bundle clove hitch into square knot. Figure 4-99. Tying a wire group of bundle. 4-57. Before assembly to these junctions, wires and cables must be cut to length. All wires and cables should be cut to the length specified on drawings and wiring diagrams. The cut should be made clean and square, and the wire or cable should not be deformed. If necessary, large diameter wire should be reshaped after cutting. Good cuts can be made only if the blades of cutting tools are sharp and free from nicks. A dull blade deforms and extrudes wire ends. Stripping wire and cable. Nearly all wire and cable used as electrical conductors are covered with some type of insulation. In order to make electrical connections with the wire, a part of this insulation must be removed to expose the bare conductor. Copper wire can be stripped in a number of ways depending on the size and insulation. Figure 4-100 lists some types of stripping tools recommended for various wire sizes and types of insulation. Aluminum wire must be stripped using extreme care, since individual strands break very easily after being nicked. Stripper wire size insulations. Hot blade rotary. Electric bench hand pliers knife. #26 for all except asbestos. #26 for all. #20 6 all. #26 8 all. #2 0000 all. Figure 4-100. Wire strippers for copper wire. The following general precautions are recommended when stripping any type of wire. 1. When using any type of wire stripper, hold the wire so that it is perpendicular to the cutting blades. 2. Adjust automatic stripping tools carefully. Follow the manufacturer's instructions to avoid nicking, cutting, or otherwise damaging strands. This is especially important for aluminum wires, and for copper wires smaller than No. 10. Examine stripped wires for damage. Cut off and restrip, if length is sufficient, or reject and replace any wires with more than the allowable number of nicked or broken strands listed in the manufacturer's instructions. 3. Make sure insulation is clean cut with no frayed or ragged edges. Trim, if necessary. 4. Make sure all insulation is removed from stripped area. Some types of wires are supplied with a transparent layer of insulation between the conductor and the primary insulation. If this is present, remove it. 5. When using hand wire strippers to remove lengths of insulation longer than 3/4 inch, it is easier to accomplish in 2 or more operations. 6. Retwist copper strands by hand or with pliers, if necessary, to restore natural lay and tightness of strands. A pair of hand wire strippers is shown in Figure 4-101. Figure 4-101. Light-duty hand wire strippers. This tool is commonly used to strip most types of wire. The following general procedures describe the steps for stripping wire with a hand stripper. Figure 4-102. 1. Insert wire into exact center of correct cutting slot for wire size to be stripped. Each slot is marked with wire size. 2. Close handles together as far as they will go. 3. Release handles allowing wire holder to return to the open position. 4. Remove stripped wire. Solderless terminals and splices. Splicing of electrical cable should be kept to a minimum and avoided entirely in locations subject to extreme vibrations. Individual wires in a group or bundle can usually be spliced if the completed splice is located where it can be inspected periodically. The splices should be staggered so that the bundle does not become excessively enlarged. Many types of aircraft splice connectors are available for splicing individual wires. Self-insulated splice connectors are usually preferred. However, a non-insulated splice connector can be used if the splice is covered with plastic sleeving secured at both ends. Solder splices may be used, but they are particularly brittle and not recommended. Electric wires are terminated with solderless terminal lugs to permit easy and efficient connection to and disconnection from terminal blocks, bus bars, or other electrical equipment. Solderless splices join electric wires to form permanent. 4-58. 1. 2. 3. Figure 4-102. Stripping wire with hand strippers. Continuous runs. Solderless terminal lugs and splices are made of copper or aluminum and are pre-insulated or uninsulated, depending on the desired application. Terminal lugs are generally available in 3 types for use in different space conditions. These are the flag, straight, and right angle lugs. Terminal lugs are crimped, sometimes called staked or swaged, to the wires by means of hand or power crimping tools. Copper wire terminals. Copper wires are terminated with solderless, pre-insulated straight copper terminal lugs. The insulation is part of the terminal lug and extends beyond its barrel, so that it covers a portion of the wire insulation, making the use of an insulation sleeve unnecessary. Figure 4-103, insulation grip. Barrel. Tongue. Wire insulation stripped wire. Color-coded insulation. Figure 4-103. Pre-insulated terminal lug. In addition, pre-insulated terminal lugs contain an insulation grip, a metal reinforcing sleeve, beneath the insulation for extra gripping strength on the wire insulation. Pre-insulated terminals accommodate more than one size of wire. The insulation is usually color-coded to identify the wire sizes that can be terminated with each of the terminal lug sizes. Crimping tools. Hand, portable power, and stationary power tools are available for crimping terminal lugs. These tools crimp the barrel of the terminal lug to the conductor, and simultaneously crimp the insulation grip to the wire insulation. Hand crimping tools all have a self-locking ratchet that prevents opening the tool until the crimp is complete. Some hand crimping tools are equipped with a nest of various size inserts to fit different size terminal lugs. Others are used on one terminal lug size only. All types of hand crimping tools are checked by gauges for proper adjustment of crimping jaws. Figure 4-104 shows a terminal lug inserted into a hand tool. The following general guidelines outline the crimping procedure. 1. Strip the wire insulation to proper length. 2. Insert the terminal lug, tongue first, into the hand tool barrel crimping jaws until the terminal lug barrel butts flush against the tool stop. 4-59. Locator. Tongue is horizontal. Stop. Barrel butts flush against tool stop. Figure 4-104. Inserting terminal lug into hand tool. 3. Insert the stripped wire into the terminal lug barrel until the wire insulation butts flush against the end of the barrel. 4. Squeeze the tool handles until the ratchet releases. 5. Remove the completed assembly and examine it for proper crimp. Some types of uninsulated terminal lugs are insulated after assembly to a wire by means of pieces of transparent flexible tubing called sleeves. The sleeve provides electrical and mechanical protection at the connection. When the size of the sleeves used is such that it fits tightly over the terminal lug, the sleeves need not be tied. Otherwise, it should be tied with lacing cord. Figure 4-105. 1. Approximate, tight or shrunk sleeve. Lacing cord. Loose sleeve. Figure 4-105. Insulating sleeves. Aluminum wire terminals. Aluminum wire is being used increasingly in aircraft systems because of its weight advantage over copper. However, bending aluminum causes work hardening of the metal, making it brittle. This results in failure or breakage of strands much sooner than in a similar case with copper wire. Aluminum also forms a high-resistant oxide film immediately upon exposure to air. To compensate for these disadvantages, it is important to use the most reliable installation procedures. Only aluminum terminal lugs are used to terminate aluminum wires. All aluminum terminals incorporate an inspection hole that permits checking the depth of wire insertion. Figure 4-106. The barrel of aluminum terminal lugs is filled with a petrolatum zinc dust compound. This compound removes the oxide film from the aluminum by a grinding process during the crimping operation. The compound also minimizes later oxidation of the completed connection by excluding moisture and air. The compound is retained inside the terminal lug barrel by a plastic or foil seal at the end of the barrel. Splicing copper wires using pre-insulated wires. Pre-insulated permanent copper splices join small wires of sizes 22 through 10. Each splice size can be used for more than one wire size. Splices are usually color-coded in the same manner as pre-insulated, small copper terminal lugs. Some splices are insulated with white plastic. Splices are also used to reduce wire sizes. Figure 4-107. Crimping tools are used to accomplish this type of splice. The crimping procedures are the same as those used for terminal lugs, except that the crimping operation must be done twice, one for each end of the splice. Emergency splicing repairs. Broken wires can be repaired by means of crimped splices, by using terminal lugs from which the tongue has been cut off, or by soldering together and potting broken strands. These repairs are applicable to copper wire. Damaged aluminum wire must not be temporarily spliced. These repairs are for temporary emergency use only and should be replaced as soon as possible with permanent repairs. Since some manufacturers prohibit splicing, the applicable manufacturer's instructions should always be consulted. Splicing with solder and potting compound. When neither a permanent splice nor a terminal lug is available, a broken wire can be repaired as follows. Figure 4-108. 1. Install a piece of plastic sleeving about 3 inches long, and of the proper diameter to fit loosely over the insulation on one piece of the broken wire. 2. Strip approximately 1 1/2 inches from each broken end of the wire. 4-60.